Welcome back, folks. We're still working with polygons here, and now I want to look at some classifications of angles. So let's say I have a pentagon. And I could say that oh, that's not a very good pentagon. I could say that the angles inside, let's say that this is a regular pentagon, even though it's drawn horribly. I could say that the sum of the interior angles here, the sum of these angles would follow the pattern or the formula of n minus 2 times 180, where n is the number of vertices that I have, and in a pentagon I have 1, 2, 3, 4, 5, so I'd say that this is 5 minus 2 times 180, and that'd be 3 times 180, so the sum would be 540 degrees. So this angle here, this angle plus that angle plus that angle plus that angle plus that angle would be 540 degrees, which, you know, seems reasonable. That means that each one of them, well, if these are these look like they're bigger than 90 degrees, and if I need to get to 500, well, I've got 5 of them, so they have to be a little bit over 100, but how much? So if I wanted to figure out what one of them is, I could say, well, there's 540 total. It's regular, so each of them is the same, so they're all 1/5 of that. So I could divide by 5, and I would say that each angle, so this measurement here, the measurement of that angle would be 108 degrees. So that would be 108, that would be 108, that would be 108, that would be 108, and this one here would be 108 degrees. Since it's regular, they're all the same, or I'd say that 1, 2, 3, 4, 5 of them gives me my 540, or if I add them all together, it will equal 540. So if I want to find out what each one of them is, if I'm just given the shape, but I do know that it's regular or equiangular, I just divide by n. Divide by n. So if I want to write a formula for that, I can say that each interior angle, that's an angle on the inside here. The angle on the inside, we'll talk about that in a moment. Each interior angle is equal to the sum of all of the angles, divided by n, divided by the number that you have, because they're all the same, they all add up to this, and there's that number of them, so you just divide to find out what each one of them is. Now I mentioned that those are called interior angles, and I didn't really explain that, but if you have a polygon, let's say you have another pentagon, you've got angles on the inside, you've got an angle on the inside here that adds up to some amount, and if you imagine, zoom in on this, if you imagine that you take that angle and you were to draw a line on the outside that extends one of the legs that's there, or one of the sides that's there, you would also come up with an outside angle. You'd also have this outside angle, and together they would make a full angle. That'd be a straight line. That would be 180 degrees. So this would be the inside. This would be the angle inside, and this would be the angle outside. And together they would make a line. Now those inside angles we're going to call interior. And as you may guess, we're going to call these exterior angles. And we say that there's one each. So like for this vertex up here, I could draw and I could extend, go back to my blue, I could extend this line here and make that, or I could extend that line there and make that. Now what would it be? This is the interior angle, so I could finish it off here to make that, or I could finish it off here to make that. And it doesn't matter, these would still be straight lines, but the idea is that we consider one extended to each side to add up. So this is an interior angle, it's on the inside of the polygon, and it also has an exterior angle, and those all always add up to 180 degrees because you form a straight line. So I could say that this here, let's say I extended that, and I'm going to call this angle, that's an interior angle, let's say that that's x. I don't know that. I don't know what that is, but let's say that this is 72 degrees. Say that angle is 72 degrees. Well, that means that together they would form a straight line. So if I took the x and I added 72 degrees, I would get to my 180 degree straight line. So I can actually use these exterior angles to calculate things that I don't know. So in this case, I'm going to subtract 72 degrees from both sides, subtract 72 degrees from both sides, and I'm going to say then that x is equal to, well, what would that be? That would be 108. So this would be 108 degrees, and that looks like about a little bit over 100. I mean, it's certainly bigger than that one, but that means that this with that together would make this straight line. This would be the exterior angle. This would be the interior angle. And just like the sum of all the interior angles here, so the sum of the interior is n minus 2 times 180. But the sum of the exterior is actually easier. The sum of the exterior angles, again, those are the ones on the outside, and we consider 1 per vertex. Exterior angles is always 360. Doesn't matter how big or small your polygon is, it's always 360 degrees. So this one's pretty easy to remember. You just have to keep it separate from the interior angles. So the sum of the interior angles increases as you increase the number of sides. It increases according to this, that the sum of the interior angles follows the pattern of n minus 2 times 180, but the sum of the exterior angles, one at each vertex, is always 360 degrees. No matter what polygon you're dealing with, as long as it's regular or it's equiangular, then it's going to be 360 degrees.